What you're seeing behind me represents a model of state-of-the-art production capable of interpreting complex customer orders generated as a result of simulated sales activity at the CSI company. This is a model business that we set up in our Lubar School of Business SAP training system, and it's a company that sells products that are comprised of both wet and dry fill ingredients. These customer orders for products are sent over to the manufacturing execution system here at CSI, which is in charge of managing that production. The teaching opportunities available in this environment include things like motion control, fluid flow management, lot size of 1, track and trace, and several applications of sophisticated AI to manage the process, to name a few. The production of these goods relies on a sophisticated, fully integrated set of tools from today's leading industrial suppliers. These tools connect the edge of our manufacturing line, right at the PLC and actuator level, all the way to the cloud, where our data is managed. Microsoft has chosen our institute as the one where their newest innovations in manufacturing will be installed, such as AI-equipped cameras, fully integrated with Rockwell MES controls. And it's the story of this integration which is the one we want to tell. It's how to create integrated IoT systems that we must teach. A well-equipped workforce is absolutely critical to achieving the GDP goals of our nation and our communities, and we can't compete on sheer muscle alone. We increase our odds of winning this race when we create a workforce hungry and capable of leading this sort of innovation through skills and knowledge acquisition, and we make that available in this environment rich with integration of machine controls with IoT. The ability to teach in this hands-on environment are the things that differentiate the CSI from all other institutes. And this unique, rich environment is where we teach. It's where we research. It's the hands-on experience working with this integrated tool set, which is the sandbox that we offer. Great minds and investments have come together to create this environment rich with promise. Use it. Come and learn, come and innovate, and connect with fellow travelers and others who share your passion for changing the world one IoT project at a time. This is my personal invitation to you.
Do a project like this where it comes down to the partners that we work with. And this is a complex engineering project with multiple companies involved, bringing together the newest technologies, but also putting a lot of thinking into this as an engineering group.
We tried to figure out what elements we wanted to make sure were incorporated. So the independent cart technology was absolutely key to this, and that was something that Michael kind of insisted we had. You know, what does the university need? What do our business leaders need as far as the partnership goes? What would we need for research? So we tasked down in Atlanta to develop a functional specification for everything we could consider. And then that became the guiding document to tie everything together. How many different forms of learning can we apply on a single machine? That was really the basis of it.
You mentioned some things that we've never done as ABT. There's things on this cell that have never been done, period. PLC motion let the PLC actually control the robot motion at a granular level. We were actually able to hook up Fanuc's RoboGuide to the physical PLCs and do a lot of debug and emulation prior to. And what's unique about that is we had all 4 robots running in one RoboGuide simulation tied up to the multiple PLCs. So we have a safety PLC, we have the robot PLC, and then a process control PLC all talking together and talking through RoboGuide. As far as programming the MagnaMotion, we got a lot of help from the MagnaMotion folks at Rockwell. It's amazing what that thing can do as far as just doing its own little self-traffic control, the speed at which it functions. We've actually had to slow that thing down to about 50% capacity because otherwise the vials and the caps on the system will fly off as it goes around corners. Latest, greatest technology, so the new Panel V5000s are out there, the L8 controllers are there, the brand new color sensors, we're using those for the dry fill capsules, so they will determine the different colors. It's the future of manufacturing.
We've been longtime partners with Enders & Hauser. We have so much trust in E&H and the way they operate and their partners.
Symbiont's aspect involves the liquid delivery portion, and really what we're trying to do is give the university some variability, both from a controls perspective and from a mechanical perspective, so that we can look at how things like varying mechanical designs, varying controls methodology, how network latency, things like that affect real-time high-speed controls, and then be able to integrate the analytics that we're looking at and say, at what pressure can we optimize this skid? Which of the 3 filling methods is the most accurate? How do we want to control our valves?
There's so much potential that can be unlocked here for learning, for applied research, for creating value. It's ready to accelerate the upskilling of US manufacturing, really to open people's eyes up to what is digital manufacturing, what does that really mean. The credit actually goes to our management team, and it really trusted us to go get this done.